Egyptian archaeologists made an extraordinary discovery near Cairo just recently. Drumroll, please. The most ancient and most complete mummy yet discovered in the country. Yes, they were keeping it under wraps. The 4,300-year-old mummy was found in a group of tombs close to the step pyramid of Djoser, dating back to the Egyptian Old Kingdom. It was covered in layers of gold. The team also found several other tombs, including one belonging to an ancient Egyptian official and another belonging to a secret keeper who had the power to perform special ceremonies. Another interesting tomb was that of a writer, which featured the largest statues ever found in the area. This vast burial site is also home to more than a dozen pyramids and resting grounds. Probably one of the most famous mummies in the world is that of Hatshepsut. She ruled Egypt like a boss for around 20 years, building all sorts of impressive buildings and creating new trade routes. But when archaeologist Howard Carter found her tomb in the Valley of the Kings, her sarcophagus was empty. However, Carter did find 2 coffins in another tomb, one of which belonged to Hatshepsut's wet nurse and the other to an unknown woman. In 2006, a team of specialists decided to investigate whether that mysterious lady was the queen herself. They found a molar tooth in a wooden box with Hatshepsut's name on it, and when they compared it to a gap in the mummy's mouth, it was a perfect match. Ramses II was a pretty impressive ruler, but it was his mummy that eventually made history. Now, we don't hear too much about his daddy. Okay, I'll stop. Ramses is considered to be the most powerful pharaoh in all of Egypt, as he reigned for a whopping 6 decades. He also lived to be over 90 years old. Now that's pretty amazing, considering the time he lived in. Ramses II supposedly had over 100 offspring too. Talk about a big family. When he passed away, his body was originally buried in the Valley of the Kings, but some sneaky guys tried to rob his tomb of all his treasures. Officials back in the day weren't having any of that though, so they moved his body to a secret location to keep it safe. Fast forward to the 1800s, and Ramses II's mummy was discovered along with a bunch of other rulers and important officials. But it wasn't in the best condition, so archaeologists flew it to Paris to get it, pampered. Problem was, he couldn't just be transported into another country. The only solution available was to give Ramses II his own passport. His occupation was listed as king, and the document even featured his photo. Most mummies aren't necessarily known for having the most hydrated skin. But that of an ancient woman, also known as Lady Di, proves otherwise. No, not that Lady Di. This wealthy lady from ancient times was discovered in an ornate tomb in 1971, and she looked fabulous, if we can say so about a mummy. Thanks to the special conditions in her tomb, like the moisture in the environment and the lack of oxygen, her body was almost perfectly preserved. Her skin was soft, her hair was on point, and she was still flexible. The museum that now proudly displays her mummy also shows a ton of fancy items that were buried with her, like dinnerware and musical instruments. Archaeologists investigated the mummy further and discovered that she passed away from a heart attack at around 50 years old. Even though it hasn't been around for over 2,000 years, Lady Di is still making history. The mummy of Otzi the Iceman was discovered in the Alps in 1991. Austrian authorities initially thought he was a modern mountaineer because he was so well preserved. Turns out, he was actually from the Copper Age. He was found in a mountain pass over 10,000 feet above sea level. Through studying his mummy, we've learned so much about life in Copper Age Europe. For example, we know that he was a native of Central Europe and enjoyed eating meat. He also suffered from arthritis, narrowing arteries, and intestinal problems. But he likely used acupuncture and medicinal herbs to treat these conditions. And apparently, he was pretty handy with tools. He sharpened them just days before his untimely demise. Who knows if he was expecting trouble or just getting ready for some routine work. Now, King Tut and his story is most likely the one that made all mummies famous. This pharaoh passed away at the young age of 19, more than 3,000 years ago. But his mummy is still one of the most well-known in the world. When his tomb was opened in 1922, people went wild because it was still intact, unlike many other royal tombs. It had some seriously blinged-out coffins, including one made of solid gold. Not only did Tut's tomb give us a glimpse into ancient Egyptian history, but his mummy also taught us a lot about the time he lived in. DNA analysis helped identify his parents and revealed that the pharaoh had a rare bone disorder that might have made walking a bit tough. Now, Ginger is most likely one of the coolest mummies you'll ever hear about. He's like a time traveler from 5,000 years ago who's still looking fly with his golden hair and perfectly preserved nails. Ginger was discovered in Egypt and is believed to be the earliest known mummified body. Before people even knew about mummification, they used to place bodies in shallow graves in the hot, dry sand. And since the sand absorbed all the water, bacteria couldn't reproduce and the body was preserved naturally. Now, scientists are not sure if Ginger's preservation was intentional or not, but since he was buried with some pottery vessels, it's likely that whoever buried him knew some serious preservation techniques. If you want to meet Ginger in person, he's currently chilling at the British Museum. One Dutch art collector bought a statue from Asia and ended up finding a weird discovery. The statue contained a mummy hidden inside. Unfortunately, the body was too fragile to move, so they had to leave it there. The coolest part is that this mummy is over 1,000 years old and was on display for 200 years before being encased in the statue. When scientists did a CT scan, they found out that the mummy was filled with paper scraps covered in writings. Experts think he might have done this thing called self-mummification, which is a pretty intense process involving a special diet and tea that makes your body less prone to bacteria. Only a few people could handle this ritual, and those who managed to do that were seriously respected. No other Egyptian queen has baffled scientists and historians like the stunning Nefertiti. Based on her statues, she was known for her slender neck, wide eyes, and high cheekbones. Her name translates to "the beautiful woman has come." Talk about living up to your name, huh? Even though she wasn't a pharaoh herself, Nefertiti still managed to leave a lasting impression. Written records suggest that, as a wife and queen, she held an incredibly influential role. Because of her power, she was indeed admired, but she also managed to make quite a lot of enemies throughout her life. She was also related to King Tut, but not biologically. Rather, she was his stepmother. So far, locals have yet to identify her mummy, but that may soon change. A local Egyptologist who has been busy excavating tombs in the Valley of the Kings has found two mummies that he believes could be Nefertiti and her daughter. According to specialists, we may soon finally get a definitive answer about the identity of these two mummies. And if one of them does turn out to be Nefertiti, we could be in for a real treat. DNA analysis and CT scans of the mummy could give us the most complete and accurate image of the queen that we've ever seen. It's crazy to think that we've only scratched the surface of what lies beneath modern-day Egypt. Nefertiti ruled during a time of great power and prosperity in Egypt, but unfortunately passed away in a period of social turmoil, leading to her gravesite being lost. Now, where's my mummy? A hole about the size of Switzerland or South Carolina keeps popping up in the Antarctic ice. This opening is growing steadily, and it took scientists half a century to figure out why. They found the answer with the help of seals. The scientists first spotted this gap, called Maud Rise Polynia, in the Weddell Sea in 1974. They were about to close the case as the hole disappeared, but it popped out again in the following 2 years, and then only in 2016. The giant hole is near Maud Rise, an underwater mountain. This type of hole is a polynia, a rare patch of open water surrounded by thick sea ice. In Antarctica, when winter hits, the ocean surface freezes, and sea ice spreads out to cover an area about twice as big as the continental United States. Along the coast, openings in the sea ice pop up every year. This happens when powerful coastal winds blow off the continent and push the ice away. But it's a whole lot rarer for these openings to form way out over the open ocean, hundreds of miles from land, where the water is thousands of feet deep. Researchers from several universities teamed up to study the Maud Rise Paulownia using computer models and satellite images. They even recruited some Antarctic seals to help out. These seals wore tiny helmets on their furry round heads with tracker sensors attached to them. Thanks to these sciencey seals, the team could collect water data from the source. After the research, the scientists discovered that the hole resulted from a complex mix of factors. The wind, ocean currents, and the special shape of the ocean floor all work together, moving heat and salt up to the surface. In science talk, this swirling movement is called an Ekman transport. Ekman transport is what happens when wind messes with the surface of the ocean. When the wind blows across the water, it creates friction that grabs onto the top layer and pulls it along. Thanks to the Coriolis effect, which comes from Earth's spinning, the moving water gets pushed at a 90-degree angle from the wind's direction. So, instead of the water going exactly where the wind is pushing it, it drifts off at an angle. Which way it turns depends on which half of the planet you're on. In the northern hemisphere, the water shifts clockwise from the wind direction, and in the southern hemisphere, it shifts counterclockwise. Now, Ekman transport turned out to be the missing piece of the puzzle in the case of the Maud Rise hole. It helped balance the salt levels and keep mixing salt and heat up to the ocean surface. But as the sea ice melts, the surface water becomes less salty, which should stop the mixing. So the scientists realized something else had to be happening to keep the Paulownia open. There had to be another source of salt. Salt lowers the freezing point of water. To find out where this extra salt was coming from, the team dug back into their data and ran more computer models on the ocean. They found that swirling currents formed as the Weddell Current flows around Maud Rise. These currents carry salt up to the top of the underwater mountain. From there, Ekman transport kicks in. As the top layer of water moves away with the wind, water from deeper down rises to take its place. At Maud Rise, this upwelling water brings along the extra salty water built up around the seamount, and that's what helps keep the Paulownia from freezing over. Scientists follow any changes in Antarctica as they influence the rest of the world. Researchers at Stanford University used machine learning for the first time to study detailed satellite data showing how ice moves in the polar region. They combined huge amounts of real-world data with physics rules to understand the Antarctic ice sheet better. It's the biggest ice mass on Earth, almost twice as large as Australia. It acts like a giant sponge for the planet, storing fresh water as ice and stabilizing sea levels. Scientists used to rely on models based on lab experiments, but real Antarctic ice is way more complex, with cracks, air pockets, and different types of ice that behave unpredictably. Instead of trying to model every little detail, the team trained a machine learning model using data from 2007 to 2018. It looked at 5 major ice shelves and created new models showing the ice's resistance to flow. They found that near the land, the ice is compressed and behaves as in lab predictions. But farther out, the ice is stretched toward the ocean and acts differently depending on direction. Less than 5% of the ice shelf is compressed. The other 95% behaves in a way old models didn't fully explain. This research could seriously improve our predictions of how Antarctica might change in the future. Another recent piece of big scientific news from Antarctica changes the history of birds as we know it. For a long time, it was simple. Dinosaurs ruled the Earth until an asteroid hit 66 million years ago and wiped them all out, except for some avian dinosaurs, which eventually became birds like eagles and chickens. Now, scientists have found a headless fossil of a VYI on Vega Island in Antarctica. The fossil was 68 million years old, at least 2 million years older than the asteroid strike. Without a skull, it was unclear what modern birds VYI might be related to, and guesses included waterfowl and shorebirds. Nearly 20 years later, another expedition found a bird's skull in Antarctica. After careful study, scientists matched it to VYI and concluded it was an ancestor of modern water birds like loons and grebes. If it's all true, VYI is now the oldest known modern bird in fossil records. The skull had a long, pointed beak, a brain unlike any other Mesozoic bird, and signs of strong jaw muscles like mine, which were perfect for diving underwater and catching fish. The body fossil also had adaptations for underwater swimming, similar to modern diving birds. During the late Cretaceous period, Antarctica was a temperate rainforest, far from the Yucatan, so it could have become a safe haven during the asteroid disaster. So, early modern birds might have survived there. When a giant iceberg, about the size of Chicago, broke off from Antarctica's massive ice shelf, scientists nearby did something no one had ever done before. They sailed straight over to check out the newly exposed seafloor. Studying the undersides of ice shelves is incredibly hard, but thanks to the iceberg A84, a 209 square mile patch of seafloor suddenly opened wide for exploration. The scientists deployed all their high-tech gear, including a remotely operated submersible and autonomous robots, to collect data about the seafloor and the properties of the water above it. Life exists almost everywhere in the ocean, from the bright, shallow waters to the pitch-black, volcanic deep sea. But the research team was really surprised to find such a diversity of life down there. They found a forest of sponges, giant sea spiders, ice fish, octopuses, huge corals, anemones, and even glowing deep-sea jellyfish. Normally, deep-sea creatures get their nutrients from organic matter falling from the ocean surface. But under a 500-foot thick sheet of ice that had been there for who knows how long, that wasn't possible. That meant the creatures had to be getting their nutrients in some completely different way. To figure out how long this hidden ecosystem had been around, the scientists studied the sea sponges. Sponges grow extremely slowly, only about an inch per year, but the ones they found were huge, so they must have been growing there for decades or even centuries. The team is hoping that the mountain of ocean and environmental data they collected during the expedition will help them understand how these ecosystems managed to thrive in those conditions and maybe reveal some completely new species that no one has ever seen before.
Welcome to one of the most mysterious and unexplored places on Earth. But what's so special about that? It's just some icy peaks and the endless snowy expanse of Antarctica. Yeah, that's right. But there's still a planetary scale mystery here. No matter how hard you try, you won't see a hidden mountain range, giant, unexplored land where no human has ever set foot, and it lies under another layer of mountains. It's like a nesting doll, but the size of a continent. These mountains hide Antarctica secrets, and these secrets can tell us something awesome about the ancient history of our planet. This gigantic unexplored territory in Antarctica is called the Gambritsev Subglacial Mountains. And the layer of ice above keeps this place untouched by nature and people. It's like a land inside another land, and it hides more than just mountains. There are valleys, hills, and plains. The whole area is similar to the European Alps, but unfortunately, we can't enjoy the view. Those mountains were first discovered in 1958 using seismological instruments. More than half a century has passed since then, and this place still remains one of the most poorly studied tectonic objects on Earth. Why? Because it's ice. A lot of ice. Who knows? Maybe there are some unknown ancient artifacts lying there. What if they're hiding a secret city or spaceships? It's unlikely, of course, but it would still be interesting to look there. Think about it. Hundreds or even thousands of miles of land that have remained unchanged for hundreds of millions of years. Even if no new species of animals or remains of an ancient civilization are there, this place still has a history. The history of the formation of continents on our planet. And scientists have already figured out some of this story. The mountains buried in Antarctica were originally like ordinary mountains, but as a result of a planetary scale event, they just… Wait a minute. Have you ever wondered how mountain ranges are formed? We see them in real life, in movies, in photos on the internet, We climb them. But how did they appear? Mountains have not always existed on the planet in this form. They appeared as a result of a large-scale collision of tectonic plates. Two giant solid chunks of ground are moving toward each other, then crash, and boom! Millions of tons of the Earth's crust pile on top of each other, mix, and form ledges and gorges. And all this can last for millions of years. Yes, it's a disaster, but it's very slow. Some tectonic plates are still colliding. For example, the Himalayas continue to grow because the Indian and Eurasian plates are still ramming into each other. And this process began about 50 million years ago. The Gambritsev Mountains under ice experienced a similar event, only much earlier. An article in the journal Earth and Planetary Science Letters says that they appeared during the formation of the supercontinent Gondwana. Two giant pieces of land were separated by a boundless ocean. But then, about 700 million years ago, they collided and formed Gondwana. This supercontinent included the territories of modern Africa, South America, Australia, India, and Antarctica. The giant pieces crashed into each other and released a stream of hot, partially molten rock. This mess grew bigger and bigger, forming mountains. The temperature of those mountains grew, their mass increased, and at some point, Gondwana became unstable. The supercontinent began to collapse under its own weight. The hot rocks below the surface began to flow sideways as a result of a process called gravitational spreading. Take toothpaste and start squeezing it out of the tube. Approximately the same thing happened with billions of tons of red-hot rock. Ancient mountains in Antarctica appeared right during this catastrophic event. You've just watched a visual simulation of global events that took place hundreds of millions of years ago. It looks cool, but how did scientists figure it out? How did they see this planetary-scale destruction? If the Gambritsev Mountains under ice is one of the most unexplored places in the world, then how could people find out its origin? The answer is simple. Tiny particles of rock have told us about the changing landscape of the planet. These are zircons, but scientists also call them time capsules. This mineral is very handy and resistant to mechanical and chemical influences. It's difficult to crush, it doesn't get affected by erosion, and it doesn't dissolve in water. And there's uranium inside it. This chemical element shows scientists the age of the rock. The fact is that uranium always decays into lead at the same rate. Scientists look at the ratio of uranium and lead and determine the age of minerals with great accuracy. Okay, this sounds a bit complicated. Here's a simple example. Imagine that each mountain belt is a clock that starts ticking at the moment of its formation. That is, after the collision of tectonic plates. After the rock forms, uranium begins its slow decay. The more time passes, the more uranium turns into lead. The rate of this decay is always the same. This decay can last for billions of years. The less uranium is in zircons and the more lead, the older the rock is. And this is how it happens in practice. Geologists take several rock samples. In a lab, they crush it to extract crystalline zircons. Geologists then dissolve the particles in acid to separate uranium from lead. Then they use a special device, a mass spectrometer that accelerates atoms and sorts them by mass. This is a rather complicated process, but the bottom line is that this device shows scientists the amount of uranium and lead. They look at the ratios of these two elements and calculate the age of the rock. Geologists took zircons from sandstones near the Gambritsev Mountains, studied those particles, looked at the level of uranium, and calculated the chronology of mountain formation. Then they compared the data obtained with the history of our planet and realized that the mountains buried in Antarctica appeared during the formation of the supercontinent Gondwana. But how did they find out that the supercontinent included Australia, India, and Africa? Zirconia from those Antarctic rocks turned out to be very similar to zirconium from those countries. That is, a long time ago, these three continents were together. So, The Gambritsev Mountains began to grow about 650 million years ago. About 580 million years ago, they reached the height of the Himalayas, and 80 million years later, they experienced the melting of the Earth's crust. And while most of the mountain ranges on the planet were changing and collapsing, the Gambritsev Mountains under ice remained untouched. Water, soil, wind, earthquakes, gravity, and other natural forces destroy mountain belts. This process is called erosion. But mountains buried in Antarctica haven't experienced anything like this. The cold temperature and the ice sheet around them kept this range unchanged. It's one of the best preserved ancient mountain belts on the planet. Okay, but why do we need to explore these mountains? What difference does it make that the supercontinent Gondwana collapsed in the past? It's possible that plants, frozen bodies of insects, or ancient bacteria have remained preserved under thick layers of ice. What about ancient animals? Many species could have lived on Gondwana. Studying ancient mountains in Antarctica can show us what the planet looked like about 500 million years ago. When Antarctica was a green continent, what lived on it? What happened to this life? Is it possible to revive those ancient creatures after so many years? If scientists were able to calculate the date of the supercontinent's appearance using tiny particles, then imagine what they could find after examining this hidden mountain range. It all sounds very interesting. But there's one problem. To take a small piece of this unknown world, you need to drill through a lot of ice. You need to deliver heavy equipment to one of the most inaccessible continents in the world, build stations, obtain an energy source, and conduct large-scale research. It sounds incredibly expensive, so this hidden territory will probably remain a mystery for a long time. Let's just hope that some billionaire will want to find out Antarctica's secrets and arrange a large-scale expedition there.
Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynya isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data. Satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the maud-rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes, or shall I say under ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen and sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever Anita has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They published the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. Anita is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Wiesel explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since Ice Cube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.